Well, hello people. Welcome to your homework feedback video for the CGP Whitebook, page 204 to 209. Same rule as always, get your green pen, give yourself marks for the one you get right, write down the correct answer in green for the question you got wrong. Let's go, same rule as always, less than 15 minutes. Can we do it? Let's see. Trends in energy resource use. Figure 1 shows the energy resources used to generate electricity in a country. Determine what percentage of the country's electricity was generated by fossil fuels in 2014. Remember, fossil fuels are oil, gas, and coal. And if you add them together, 35 plus 23 plus 5 is 63%. Suggest one trend you can determine from the graph in figure 1. So we can see that there is a little bit more of renewable energy being used from 2014 to 2015. And that's pretty good, 3% more. In the UK, the use of renewable energy resources is increasing, but many say it's not increasing at a fast enough rate. Suggest reason for this increase in the use of renewable energy resources. Suggest and explain the factors that may affect the speed at which we use more renewable energy resources. So there is a better understanding of negative effect of fossil fuels on the environment. So more people want to switch to renewable energy resources with less impact on the environment. Because fossil fuels are running out, we need to find alternatives, and there is a pressure from the public and other countries that may lead to more funding and make private companies develop alternatives to fossil fuels. What's limiting is building new power plants cost money, a lot of money. Some renewable energy resources are less reliable than fossil fuels. Okay, so like wind turbines can only work if it's windy, etc., etc. So research into improving renewable energy cost money, and objects using renewable energy resources, such as electric car, are generally more expensive. So those are the limiting factors. Let's go to a bit of electricity. Draw lines to match circuit symbols AD to their correct name. So remember, the switch is something that you open and close to let the current flow through a circuit or not. The filament lamp is the circle with the cross inside. A fuse, which is D, is used to cut the current. Is going to melt if too much voltage is traveling through, and is going to stop the current from flowing, which is going to stop a potential fire in your house. And the cell is represented by A. The long one is positive, the short one is negative. Figure 1 shows a simple circuit featuring a 10 ohm resistor. Remember, a resistor is a sorry. I lost my word. It's something that is going to make it more difficult for the current to flow through a circuit. Explain why there is no current in the circuit. So if you look at figure 1, there is no cell and no battery, no power supply. So there's no current. Use a word from the following list to complete the sentence below. Current is the rate of flow of charge. In a circuit, it's going to be electrons, but it could also be ions in the solution. Okay, but you need to know this definition by heart. Current is the rate of flow of charge. Figure 2 shows two ammeters, A1 and A2 in a circuit. The reading on A1 is 0.5 amps. What is the reading on A2? It's also going to be 0.5 amps, because in a series circuit, the current is the same everywhere. State the equation that links electric charge, time, and current. You need to know this one. The charge equals the current times time. The symbol for charge is capital Q and it's measured in coulombs. The symbol for current is capital I and is measured in amps. The symbol for time is lowercase t as in measured in seconds. Calculate the charge that flows through component X in 2 minutes. Give the unit in your answer. So here you have to convert the time in seconds straight away. 2 minutes is 120 seconds. We know the current is 0.5 amps, so we need to multiply 0.5 by 120 to find 60 coulombs. Okay, you need to know the charge, and you will be given this formula, but it's good to know. Current of 3 amps flows through a 6 ohms resistor. Calculate the potential difference across the resistor. So the formula for this one, potential difference equals resistance times current. The resistance is 6 ohms, we don't have to convert it. The current is 3 amps, we don't have to convert it either. Therefore, the potential difference is 18 volts. The students investigated how the resistance of a piece of wire depends on its length. The circuit she used is shown in figure 1, her results displayed in table 1. So you can see that the longer the length, the higher the resistance. Describe how the students could have used the apparatus in figure 1 to obtain the results in table 1. So students should measure the length of the wire using a ruler. Okay, then they're going to turn on the equipment, measured the current, measure the voltage, and we know that resistance equal potential difference divided by current. So change the position of the crocodile clips to change the length of the wire. You can use a use a ruler to measure the length of the wire. Use the readings of the voltmeter and of the ammeter to calculate the resistance using the formula R equal V over I. Plot a graph of the data in table 1 on the grid shown in figure 2. I did it for you. Label the axis correctly. Draw a line of best fit on the graph. So the length is the independent variable. It goes on the x-axis, and we need to go from 0 to 50. So each big square is 10, and the resistance must go from 0 to 3. So the best way is two big square are 1 ohm, and that goes on the y-axis because it's the dependent variable. And the line of best fit has to be a straight line starting at the origin. State one conclusion the student can make about the relationship between the resistance of the wire and its length. The resistance is directly proportional to the length of the wire. We have a straight line passing by the origin. Okay, this is a definition of directly proportional. It has to be a straight line. It has to go through the 0, 0 point. Figure 1 shows some graph of current against potential difference. Tick the box below the correct graph for a resistor at constant temperature. So if we work at constant temperature, the current is directly proportional to the voltage. We should have a straight line passing by through the origin. It's therefore number C. Name the type of graph shown in figure 1. It's IV characteristics graph. So I for current, V for potential difference. Use words from the following list to complete the sentence below. A resistor at a constant temperature is an example of an ohmic conductor. It follows the Ohm's rule or the Ohm's law. It is also an example of a linear component. Okay, because it's going in a straight line, passing by the origin. This question is about diodes. Draw the standard circuit symbol for a diode. So you have a triangle like this and a line indicating that the current can only go from left to right. An old name for a diode is a valve. A valve is a bicycle pump, only lets air flow through in one direction. In what way do diodes behave in a similar way to valves? The diode only lets the current flow in one direction. A student measured the resistance of a diode using an electric circuit. He found the resistance to be 0.02 ohms. The next day, he measured the diode again. This time, he measured the resistance to be 100 megaohms. That's huge. Suggest why the student's measurements were so different. You may assume that the circuit is working perfectly on both occasions. So what they may have done is connect the diode in the opposite direction. Okay, on day one, the resistance is really, really small, so the current can flow easily. On the second day, the resistance is huge, which means that the diode is connected in a way that it doesn't let the current to flowing. So the student put the diode power supply in a circuit the other way around. So either they put the diode or the power supply the other way around. So the resistance of a diode is very weak one way and very high the other. Okay, so you must have switched the position of either the diode or the power supply. Next, a student used the circuit in figure 2 to find the IV characteristic of a filament lamp. Explain the purpose of the variable resistor in a circuit. You can use the variable resistor to adjust the current. Okay, therefore you can measure the potential difference for different currents. So you're going to use this to change the current, and then you're going to use the voltmeter to measure the potential difference. The student obtained the graph displayed in figure 3. Use the graph to find the resistance of the lamp at 3 amps. So 3 amps is for the current. You're going to draw a line, and you find out that the potential difference is 12 volts. The resistance equal to the formula, resistance equal potential difference divided by current. The potential difference, V, is 12 volts. The current is 3 amps. No need for the fine tune. We have everything we need in the right unit. Therefore, the resistance is 4 ohms. Please, please, please show all your work to get those marks, okay? What does the graph tell you about the lamp's resistance as the current increases? Explain why the resistance behaves in this way. So we can see that past 6 volts pretty much. When you increase the potential difference, you increase the current, but not as much. Okay, so the resistance increases when the current increases. And this is because the temperature increases when the current increases. And when it gets hotter, the resistance increases because the atoms are moving more, therefore it's harder for the electron to travel through. The student states that the lamp behaves as an ohmic conductor up to a potential difference of approximately 3.5 volts. Explain what has led the student to this conclusion. We have, if you look carefully, a perfectly straight line for the first 3 volts. So a conductor is ohmic when the relationship between current and potential difference is linear. The graph is linear until about 3.5 volts. Next, question 4. A student created a test circuit containing a diode as shown in figure 4. Describe a method the student could use to investigate how the resistance of the diode change with current. So he's going to build up his circuit. Use the variable resistor to adjust the current. Use the reading of the ammeter and the voltmeter to find the current and the potential difference across the diode. Use the formula R resistance equal potential difference divided by current to find the resistance, and repeat for different currents, at least 6, and then use the variable resistor to change the current. Molto facile. The student carries out the experiment and plots her results on a graph shown in figure 5. So you have the current in milliamps on the x-axis and the resistance in kiloohms on the y-axis. Draw a curve of best fit. So again, it's going to be a smooth line passing as close as possible to all the points. The students say, from my results, I can conclude that the greater the magnitude of the current through the diode, the lower the resistance. Explain why the student cannot make this conclusion from her results. They have only used positive values of current. Okay, remember current can flow in both directions. So they can't make that conclusion because they have only studied the current flowing in one direction. Okay, and if it's a diode, if it was the other way around, it may not work this way. Okay, this is it for today. Ooh, that was a short one. Well done, me. Make sure you have all the correct answer in green on your CGP whitebook. Make sure you bring it back to class if needed. Make sure you keep on revising hard. All right, guys, stay amazing, and I will talk to you again very soon. Bye bye.